In this video, we're going to talk about what a polynomial inequality is and the steps to solving nonlinear inequalities. So first we'll begin by saying let f of x be a polynomial. So basically that means, or from there we can say that if f of x is less than 0, or if f of x is less than or equal to 0, or f of x is greater than 0, or f of x is greater than or equal to 0, that these are going to be called polynomial inequalities. Now, a polynomial inequality is nonlinear if f of x is a polynomial of degree greater than 1. So if we take a look at this example, we have the following function. F of x equals x squared minus 6x plus 5. Now notice that our degree is a 2, which means that this is non-linear because it's greater than 1. And we also are given its graph right here. So what are the solution sets to the following three inequalities and equations? So essentially here, it's all about getting our function on one side and setting it equal to 0 or less than or greater than to 0 on the other side. So we want to know essentially here, where is x squared minus 6x plus 5 equal to 0? So we take our equation and we set it equal on one side and to 0 on the other side. And from our graph, we can see that that happens in two places. It's equal to 0 here at 1 and here at the 5. Thus, we can say that the solution set would be 1, comma, 5, or when x equals 1 and x equals 5. Now, in order to find where our f of x is less than 0 and where our f of x is greater than 0, we need to determine the intervals over which our function is either negative or positive. So where is it above the x-axis and where is it below the x-axis? So here for less than, we're looking at where our graph is below the x-axis because we are trying to be less than 0. And so we can see that that occurs on this portion of the graph right here, this blue portion. I'm making it a little bit bluer. Maybe I'll make it a dark blue. So from here to here, see that? That is where our graph is below the x-axis. So we can see that that is occurring between the numbers 1 and 5. So our boundary points are the 1 and the 5. So to write our answer, we would say that that occurs between 1 and 5. So we're using that interval notation, right? So now if we want to know where is our graph above the x-axis, because now we're looking for greater than 0, so that would be above the x-axis, we can see that that's happening on these pink parts right here. I'm going to do it in red, right here, right, and right here. So those are above our x-axis, right? These are above. And that happens from our boundary point of 5 and then greater than, and from our boundary point of 1 and less than. So here we're able to say that f of x is greater than 0 on the interval negative infinity all the way to the number 1, and then from the number 5 all the way to infinity. So these are our solutions right here. So here's our solution for A, here's our solution for B, and here's our solution for C. So what are the steps that we just took to solve this linear inequality? So first, we're going to write it in the form of either f of x equals 0, which would be an equation, but f of x is greater than 0, less than 0, greater than or equal to 0, less than or equal to 0. That's how we want to write it in that form. And that's what we did right here, right? We had it written in that form. Second, we want to find our boundary points. Now remember that our boundary points are pretty much where it equals the 0, right? Because these became our boundary points, which is where things were either below the x-axis or above the x-axis. So those are our boundary points, right? Those are our boundary points. So we want to find those second. Third, we want to know where are we above and where are we below the x-axis. So like here we were above, but here we were below. And so that's what we want to find. Where are we positive and where are we negative? Fourth, we want to know, are the boundary points included in the solution set? So in this example that we did, right, those parts right there, it's a really difficult color to see. Let's try this. These were strictly greater than and strictly less than. If they had been, for example, for letter B, if this said f of x is less than or equal to 0, then my answer would have been 1, 5, but with brackets, because it's included. And if for letter C, it had been greater than or equal to, then I would go from negative infinity to 1, which would be included, and then from 5, which would be included, all the way to infinity. So we have to decide, are our boundary points included or not included? So it really just depends, can it be equal to it? And then the last step is to write the answer in interval notation or set builder notation, which is what we did right here. And so that is what in polynomial inequality is and how you can solve a nonlinear polynomial inequality.